So our first speaker is Dorivar Ruiz Diaz. Many of you guys might know Dorivar. He's our soil fertility specialist at K-State, and you might hear him on the radio as much as you see him in person out here, because he spends a lot of time out here, but he's also on the radio a lot too. So if you have questions, this will be pretty relaxed. Go ahead and ask him as we go, and we'll get moving. John, you look like you have a question before we start. No, okay.
Okay, good morning. Okay, like Jeannie mentioned, again, we'll try to keep this informal as much as possible. Please stop me anytime if you have comments, questions. I think that's really the main benefit of these meetings, is to discuss what you guys are seeing and obviously questions that you have. The idea for this morning is I will start talking about a few topics, focus a little bit more on phosphorus, just touch a little bit on nitrogen, and then what other nutrients maybe we need to be thinking about as we're trying to, make sure and get some efficiency, yields, touch a little bit on things like inhibitors for nitrogen and have that discussion. And then Lucas Hegg is going to be focusing more on nitrogen and especially looking at the economics of nitrogen, okay? And Peter Tomlinson is going to focus a little bit more on using manure sources for nutrient. Of course, with the prices of fertilizer, that obviously is a good opportunity, and so we'll spend a little bit more time on that. So that's kind of the plan for this morning, and we'll finish with lunch. Okay, let's see if this works. Okay, so again, like I say, that's sort of the key topics I like to talk about: phosphorus, options for management, sufficiency versus drawdown options that we have, and again, putting that a little bit in perspective from the economic standpoint. And on the nitrogen side, again, economic optimum, and I would like to spend a little bit time on this, but Lucas will really expand on that, the economic optimum nitrogen and what opportunities we have for improving economic return to nitrogen there. And then I'll also just touch a little bit on other nutrients, especially sulfur and high pH, which again is something that we often talk about in this part of the state. And so when we talk about phosphorus, this typically is the overall model that we follow. We basically have two scenarios for phosphorus, okay? And what we have here is a relative response to phosphorus. Soil tests here, this is MELIC3 in parts per million. And one thing I want to emphasize, and I'll talk a little bit more about this, but when we talk about phosphorus tests from the K-State standpoint, we usually talk about MELIC3. So pretty much all the numbers we have is using MELIC3, using 6-inch sampling depths, okay? And this is important because there are differences when it comes to different test methods, and we have to keep that in mind, okay? So just keep that in mind. Obviously, oftentimes we talk about part per million, but again, that can mean maybe different depending on the test that we are using. So again, MELIC3, 6 inches is basically what we are using. So essentially anything below 20 part per million using that method, we're talking essentially what we call a sufficiency, which basically is a responsive range where we basically need to do applications to basically get that close to the maximum yields. And so again, that's one situation. Now the flip side of that is when we have high testing phosphorus, which is basically a non-responsive range. And again, we'll talk more about manure fields, for example, that could be already quite high. Obviously, in that situation, we don't need to necessarily do a phosphorus application. We'll talk a little bit about starter fertilizers. That could be one thing that we need to think about, but certainly we don't need to apply the typical rates that we're going to do for removal or based on recommendations. And so that's a good thing. If you have fields that are high on soil tests, a year like this, obviously that's pretty good news, right? You don't have to spend money necessarily on phosphorus as much, except maybe starter fertilizers. And again, that's obviously pretty good given the prices that we have today. Okay, so again, one of the things with this sufficiency situation where we have lower or responsive range of soil tests, not much flexibility. We really need to do applications phosphorus application. Otherwise, yields will basically be low. And so I'll put a little bit of put that in context in terms of economics with the prices today and see where we are basically getting our money back when it comes to phosphorus, depending on soil test. And I'll show you a graph here in a minute. And again, the sufficiency of build and maintenance approach, where we have plenty of phosphorus in the soil, basically kind of money in the bank, if you will. You have that phosphorus, again, it's not going anywhere, it's not mobile, it will be there. In that situation, we do have a lot more flexibility, right? And what's the advantage with that is that, obviously phosphorus is not required to apply every year. And a lot of that depends on, the cash flow and price and all of that. So again, those of you who have high testing soil test phosphorus this year, again, it's a good news. We don't need to necessarily do any application of phosphorus, right? The one thing with that I want to emphasize that what happens if we are not doing phosphorus application for multiple years? What's going to happen to soil test P? It's going to go down, right? And so it's not something that we can do for very long. And so that's just something to keep in mind. Even if we are high testing phosphorus, we can skip application or reduce applications for a couple years, a few years, depending on how much phosphorus we have. But again, long term, that soil test P is going to go down.
Is there on the phos? I mean, is there a chart like on nitrogen for every bushel of corn you come out and use so many pounds? Is the phos the same way?
Yes.
So if you raise 250 bushels of corn, how much phos is with that?
Excellent question. And actually, the case of phosphorus is even more precise than nitrogen. It's pretty much like a checking account. You can count on that with phosphorus. And for corn, we usually say about 0.3 pounds of P2O5 is that you're removing with 1 bushel of corn. And so again, at 200 bushel corn, it's going to remove somewhere around 66 pounds of P2O5. Okay. And so that's going to obviously, again, if you're thinking about that relationship of drop in soil test P, 20 pounds of phosphorus that you're removing is going to drop 1 part per million of soil test phosphorus over time. So you can pretty much track that very well in phosphorus. Obviously, there's going to be some variability and you still need to soil test, but that removal basis is pretty good way to keep track of what's going on. And again, you mentioned 250 bushel corn, irrigated corn, you can pull a lot of phosphorus, with that kind of yields. And so I think that's a very good point because, sometimes we don't realize how much we are removing with high yields, especially irrigated corn. And so again, that soil test can drop pretty quick. So again, even if we are high testing P, keep that in mind. It's not something that we can keep that for too long. Good comments, questions. Any other questions? Okay, so I have this graph, and the idea with this is really to put a little bit in context the economics and at what point we are getting our money back with phosphorus fertilizer, in the year of application. And this is based on 12 sites that we have across the state last year, and we have more sites this year, so it's an ongoing project. But what we have in this graph is soil test phosphorus against Melic 3. Again, we have our highest soil test P was close to about 50 part per million. And this is return to that phosphorus fertilizer application using these prices, okay? And so again, I don't know if it's accurate. At this point, I did it before in early December, but that's the price that I use. And so what we have here is basically, again, at what point basically that return to phosphorus fertilizer becomes positive. And this is using 60 pounds of P2O5. Okay, so keep that in mind. That's what I use. Obviously, that can be different depending on what rates we are recommended. But I use 60 pounds, a little bit based on that removal basis. Assuming somewhere around 200 bushel corn. Question?
Yeah, this is 200 bushel corn that you're figuring.
Yes, essentially 200 bushel corn and giving that 60 pounds of P2O5. And again, that will vary, obviously, your numbers depending on what you're using. The other thing too is that maybe what's more important here is that how much is this going to change? The break-even point may not change as much. I think the slope of this line is what's really going to change when it comes to using different rates for phosphorus fertilizer. So again, 60 pounds a little bit maybe on the high side. Just want to clarify that. But the main point I want to make here is that at what point in soil test P, we are starting to basically get on the positive side in the year of application. And somewhere, based on our data from last year, somewhere around close to 20 parts per million. I would say 17 to 20 parts per million. Anything lower than that, we're seeing a positive return to that 60 pounds of P2O5. Now, this is in the year of application. What happens if you're sitting somewhere, I don't know, 35 parts per million and you're still putting phosphorus fertilizer? You're not getting your money back this year, but what's happened to that phosphorus long term? It's gonna be there, right? Is it mobile? It's immobile. It's not. We are not losing. It's not like nitrogen. So long term, that phosphorus is gonna be there. The only thing is that you're not getting your money back this year. So that's basically when you think about phosphorus, it's a little bit different, obviously, well, quite different than nitrogen, because we're really thinking about more of a long-term management, right? So you can still put phosphorus here. You're not gonna get your money back this year, but obviously you're gonna get it over time. In other words, it's not really a loss, but obviously with the price of phosphorus this year, I will not be putting phosphorus if I have enough in the soil this year. That's really the message here. So I think I just wanted to clarify that again. It's not, obviously it's negative in the year of application, but long term we are not losing that P. Questions, comments? Okay. So again, this gives us a little bit of an idea of where we are in that question of, if you are staying somewhere around that 20 parts per million, I'm gonna make money on phosphorus or not. And I think that's a question here. One thing that's very clear is that if you have low testing P, yes, you're gonna make money, no question about it. We need to do application of phosphorus. So again, that's not no question about that. We have to be careful in that situation not to cut back if we have the potential for response. Now, the other thing, and this goes back to the question earlier, what about different rates? And, if you are follow K-State recommendations, if you are sitting somewhere around, close to 5 parts per million soil test P, the recommendation is going to be 70 pounds of P2O5. If you are in that range of close to 15 parts per million, it's going to be closer to 30 pounds. And if you are close to 20, it's going to be 15 pounds of P2O5. Okay, so just has to put a little bit in perspective my numbers here that I use 60. So obviously, again, if you have lower rates of application, these numbers obviously will look better, right? Okay. Okay, and you should get a copy of this as well. Hopefully in a minute, as coming the handouts. So the other question, and I mentioned a little bit starter fertilizers earlier. What about starter fertilizers? And is that going to pay to do starter fertilizers, even if you are a little bit on the high side for phosphorus? And I use the same data, same 12 locations from last year, range of soil test P, mainly 3. And what I have here is yield response in bushel, okay? So obviously lower soil test P, you're getting pretty good yield response, over 30 bushel easily in some cases. But what I'm really wanted to highlight here is what happened in this range of somewhere 20 to 30 parts per million soil test P. Okay, and this is, we will say in this situation, you don't need to do any applications. However, based on this data, we are getting a little bit of yield response in this case. How many bushels? I don't know, 2 or 3 bushels maybe. And this is where a starter fertilizer becomes a little bit of a gray area, because you may or may not see that response. And if you see a response in this range, it's going to be small. Okay. And so if you do the math again, let's say you're sitting somewhere between 20 and 30 parts per million soil test P. You're questioning whether or not you need to do starter fertilizers. Based on this, we're getting, let's say, 3 bushels, 2 bushels. How many gallons of 10-3-4-0 you can buy with 2 bushels of corn? I don't know, 2-3 gallons, something like that, maybe. I don't know. But again, I think I will justify definitely starter fertilizers if you are in that range of 20 to 30 parts per million. I think you can pay for that. Now, again, when it comes to starter fertilizers, there's a lot of moving parts there, depending on why you're using. In many cases, you know, I hear some people say, I like to use starter fertilizers because even if you are not seeing the yields, I have early growth, good coverage early in the season. You know, it's not blowing or anything like that. And I like that, which I think is a good point, you know, and just having that early growth and establishment can translate into, you know, other benefits. So I think that's a little bit of the question with starter fertilizers. And I have this, I always mention this, I have a colleague in Minnesota, was a friend of mine from grad school, and he always talk about starter fertilizers, and he said he really likes, they use starter fertilizer regardless in Minnesota, but they don't really worry too much about the yield, but drying at the end of the season. You know, lower moisture at the end of the season for them make a big difference because they don't have to dry the grain. You know, so again, things like that can be a factor for starter fertilizers. Questions on this? Comments? Okay. Okay, so the same type of data, and this is using 21 sites. This is for wheat. And I use the same type of calculation. This is using 40 pounds of P2O5. And this is using, you know, broadcast phosphorus in the fall for wheat. And kind of a similar situation. One thing that's very clear in this case is that critical value is higher than corn, okay? Now we are looking at somewhere around 25 parts per million is that break-even point for wheat. And so one thing that's very clear in this case is that, you know, that critical value, and I have to say, you know, K-State recommendations that right now we're using 20 parts per million for all crops, but that's not really what's happening. I mean, the different crops are basically responding differently to phosphorus. And we know wheat is pretty responsive to phosphorus, okay? And so this is the data clearly shows that we probably need to be somewhere at least 25 parts per million salt SP for wheat to really, you know, be in that critical value point, okay? It's just more responsive. And now if you are, there are other factors as well when it comes to wheat response to phosphorus placement. You know, if you are putting that phosphorus with the drill, with the air seeder, you see even better response, okay? And so I got the question yesterday, I mean, again, this is based on broadcast. What if you put in all the phosphorus with the air seeder? I suspect we're gonna be, you know, closer to that 30 parts per million really in that situation. We're really gonna be even higher. We tend to see even higher response in that situation for wheat. The other thing, again, just wanted to kind of highlight, there's a lot more noise here for this data compared to corn. And there's a lot of other factors affecting response in wheat, and things like planting dates. You know, if you're planting a little bit later, we tend to see better response to phosphorus. And a lot of that is obviously because you are getting some tillers, establishment, anything you can get with that late planted wheat, you get a little, you know, that's translating to yields. And so again, we do see a few more factors affecting response for wheat. Questions, comments? Okay. Obviously, all of this is assuming we have good soil test information, right? And so I'm not going to spend much time on this. I will show you one slide now in terms of the methods that we are using, but you know we have to get plenty of cores, you know, good quality, you know, sampling depths, all of that. We have to follow the guidelines. So again, just put a little bit in perspective, and Lucas is going to talk more about this, but you know, the value, the dollar values that you can put to soil test information is huge in a year like this, where you have opportunities actually to make money if you have good information when it comes to soil test. How many of you do grid sampling? Several hands, good. Grid sampling, obviously a good option to you know, improve efficiency, putting that fertilizer where it's needed. I usually say grid sampling when it comes to variable rate, certainly lime is on top of the list. If you are, you know, obviously we don't have that issue necessarily here, but you know, if lime application definitely needs to be variable rate, then next in the list usually is going to be phosphorus. If we can do variable rate application of phosphorus, again, huge opportunity there to improve efficiency and return to investment. And then nitrogen, of course. that would be my list of when it comes to variable rate. Okay, so I talk a little bit about the soil test methods that we are using. And again, like I say, MELIC 3 is kind of it is the default for us at K-State. I will say also most of the main labs we use in the region, you know, Servitech, World Labs, they all use MELIC 3. And so again, that tends to be kind of the default. However, if we're sending samples to other labs more in the Corn Belt, you will start to see a lot of break 1, okay? And so what is the challenge? What is the things that we need to pay attention to? And you know, MELIC 3 compared to break 1 is pretty straight relationship. So basically 1-to-1, except if we have high pH soils. And what's the break, you know, the critical value here is a pH of 7.4 and higher. If you do have pH 7.4 and higher, you know, break 1 is really not the best test that we should be using. Just keep that in mind, okay? And again, many of you are very aware of this, but again, it's important to keep that in mind as we are using more labs that are becoming more, you know, now it's pretty easy to ship a sample in Indiana and it's gonna be there tomorrow if you wanna do that, right? And obviously they're focusing more on those regions where break 1 tends to be kind of the standard, okay? Obviously for us, Olsen or bicarbonate tends to be obviously pretty good. It's a method that was developed in Colorado, so really intended for high pH soils, good option for us. And so again, compared to MELIC 3, pretty good relationship as well. The one that we've been evaluating more in recent years is the Haney test, the H3A, which is this one here, compared to the MELIC 3, and it basically has the same issue in high pH soils, similar to break 1, okay? And I'll often get this question, is Haney test a better test when it comes to fertility? And based on what I see, I don't think, I wouldn't say it's better. I think it's a good test, and actually in many cases comparable to things like MELIC 3. So when it comes to fertility, I don't know that I would say that's necessarily a better test. I think it's a good test and it's an alternative. However, obviously Haney test has many other things when it comes to soil health, and I'm not talking about that. So that's another topic. But again, can we use it for phosphorus? Yes, we can use it. We have data for, you know, correlations and things like that. But if MELIC 3 is doing a good job, why will we change? I think that's my take on that. Comments, questions on this? Yes.
What depth do you recommend?
Yes, what depth? And this is very important because one thing, when it comes to phosphorus in particular, we have stratification of phosphorus, especially no-till, right? And so higher concentration near the surface. So consistency in sampling depth becomes pretty important. All of our data and our interpretation at K-State is based on 6 inches. So that's really what we recommend. However, I know some labs use different depths. They may use 8 inches, is pretty popular. And to me, that's fine, as long as we are consistent and as long as we follow in with that lab when it comes to that recommendation. So that's very important. Peter.
And I just add, NRCS programs in the state are based, for phosphorus, are based on the 6-inch soil.
Yes. And so that's, if you are part of that program, then you need to follow those guidelines. And again, what I want to emphasize is we've done some studies here looking at the stratification and how that affects, you know, the numbers, and especially no-till, that can make a huge difference. You know, if you think you are collecting 6, but it's only 4 inches, numbers will come back basically higher, and all of that's going to play a role. Good question. Any other comments, questions? Okay. So again, variable rate application, we touched on this already. Again, I think there's huge opportunities. I saw several hands doing grid sampling. I think, again, to me, that's really an excellent opportunity to put nutrients where it's needed. In a year like this, I think it's definitely, you take advantage of that. So starter fertilizers, we kind of talk about this already a little bit. And this is data from obviously irrigated corn. multiple locations. But one thing I want to emphasize here is this is really on the low testing phosphorus sites. And so NPK, in this case, we are getting about 8 bushel increase with that starter fertilizer. So again, especially we are getting low testing P, starter fertilizer, so obviously it's going to translate into yields. What the data I showed you earlier, we're talking, I don't know, 2 to 3 bushel. If we are lower on soil test P, we can easily get, 5 to 8 bushel increase. One thing I want to emphasize, and the reason why I'm showing this is that, we talk a lot about phosphorus when it comes to starter fertilizers. But in reality, we do get a lot of benefit from the nitrogen as well, okay? So it's not just the phosphorus contributing to early growth and establishment, it's also the nitrogen. So, depending on the program you have, if you're doing, putting nitrogen with the irrigation system or split application later, putting some of that nitrogen with the starter can obviously help. We're going to talk a little bit more about sulfur as well and other micros. If we need to do any of that application, starter fertilizer will be the best way to do it. So again, there are other things when it comes to starter fertilizers, not just phosphorus. Obviously, other nutrients can be will be an opportunity to do applications. Micronutrients, and again, this is starter fertilizers. These are 2x2, half pound of zinc, chelated zinc. This is in sorghum, and again, with the zinc, we got a yield response in this case. With micronutrients, and we've done a lot of work with micros, and really zinc is the one that obviously we need to pay more attention to. And the soil test for zinc works pretty well. In this case, this is a location where we have 0.6 part per million soil test zinc. The critical value is 1 part per million. So anything below 1 part per million, we need to be thinking about zinc application. Based on our data, really we start to see more consistent yield benefit when it gets below 0.7 or so. Okay, so keep that in mind. Obviously, and I'll touch a little bit on iron chlorosis, which again obviously is another issue for this part of the state, but that's really a different challenge. Soil test for iron is not necessarily very good. Really need, and we'll talk more about that. But from the micronutrients, zinc is the one that I would pay more attention to when it comes to soil tests. Okay, so I'll switch a little bit and just touch on nitrogen, and again, Lucas will talk more about this, but just wanted to introduce this concept of economic optimum nitrogen versus the maximum agronomic nitrogen. And we often talk about nitrogen application rates, and seems like we have in mind really the agronomic rate. What's going to be that optimum nitrogen rate? But we tend to think more in the agronomic standpoint, but really we should be thinking about the economic optimum, because obviously nitrogen is not free, right? If it is free, then obviously we want to go for maximum, but given the prices, we really need to be targeting economic optimum. And so this is a regression line that was developed based on close to about 120 locations trials that we have in Kansas. And what you have here at this point here is the agronomic maximum nitrogen, and the economic optimum nitrogen usually will tend to be lower than that. Okay, how much lower basically depends on how expensive the nitrogen. Okay, if nitrogen is cheap, we usually put it close to this point. If nitrogen is expensive, we start to go down in that optimum economic optimum. So just keep that in mind, because the question I often, obviously now, is how much can I cut back on nitrogen? And we need to be thinking about this, okay? How much we can cut back and still be in that economic optimum. And I'll show you what could be the impact of that. And this is, I hope you can see that this graph well, but what I have here is the net return to nitrogen fertilizer. This is nitrogen rates here. And this basically the numbers you have here is the corn to nitrogen ratio, price ratio, basically how many pounds of nitrogen you can buy with 1 bushel of corn. Okay, and so here in the 12, which is the upper one, obviously nitrogen is pretty cheap. You can buy a lot of nitrogen with 1 bushel of corn. Here in this opposite situation, in that ratio of 5, nitrogen is pretty expensive. Today, we're probably close to that 5, right? Somewhere around that number. $1 nitrogen and about $5 or more than $5 corn. And so what do we see here? First of all, you know, if you look at the historic number, and you can think about your historic ratio of corn to nitrogen prices, I would say we probably been historically close to, I don't know, 7, maybe that ratio, something like that, depends on what number you use. Today we are somewhere around 5. What is the difference here in optimum rates for maximum return? And it's not a big difference. This is somewhere around 15 pounds, maybe. No more than 20 for sure. And so certainly no more than 10% reduction in nitrogen rates. So, okay, thinking about economic optimum, and if you're thinking about, okay, how much we can cut back to still be in that economic optimum, certainly no more than 15 pounds or no more than 20 pounds. 10% is probably the most that we should be cutting back on nitrogen. Okay. So yes, if we are targeting the economic optimum, yeah, we should be thinking about cutting back. However, not very much. And why not very much? Because if you look at the slope of these, if we are much lower, obviously that return is going to start to go down pretty quickly. Okay, so certainly we don't want to be cutting back too much. And that's I think is the key message here. So a few things in this graph that I think is interesting. The first one that I really mentioned already. I don't think we can cut back too much. We have to be careful with that. The other thing too is that, you know, when we have more expensive nitrogen, the penalty basically for over application is a little bit worse than if you have cheap nitrogen. And I think that makes sense, right? If you're putting too much nitrogen, nitrogen that is expensive, obviously you have a little bit more reduction in return compared to cheap nitrogen. So those are a couple of things. So again, those are kind of the take-home messages here that we just mentioned. Comments, questions on this? Yes, one thing that we see, especially, that's a very good question, and I see that oftentimes for many reasons. Maybe because we cut back, maybe also because we didn't have the expectation for higher yields. Some years we have better yield potential, and we didn't expect that, so we were a little bit short. And so one thing that we see with the new genetics is that we can put nitrogen later today and still get good response. That's something that changed a lot in recent years. The new genetics basically is taking up nitrogen later compared to, you know, old genetics. And so that gives us basically a bigger window for that nitrogen application. And so that's a good point. Now, to the question of already yellow corn, to me at that point, you're obviously already losing some yields. That's always my thinking. You know, you already have some stress at that point. You're probably losing a little bit of yield. How much? It's hard to tell, but obviously not going to be 100% anymore, right? And so, but obviously we can recuperate and we can see a good response with late applications. And we have some studies with applications up to TASO. And even at that point, if we do have shortage of nitrogen, we do see a response to nitrogen apply even to that point. Obviously, that assuming that we have either rainfall or irrigation to move that nitrogen in the root zone, which is a big factor. You know, if late application in dry land and just sitting there, obviously that's not going to work. Good comments, questions. Anything else on this? Okay, so let's switch a little bit on the other question I often get is what about inhibitors, and do we have opportunities there to, you know, improve efficiency and maybe make some money with inhibitors? And I think there are some opportunities there. I think the key is that we have to recognize in what situation can we benefit from some of the inhibitors or nitrogen products. And so this is one that to me maybe is more relevant for you guys in this part of the state, which is urease inhibitors. This is data from a couple years, irrigated corn, looking at two products, you know, the traditional Agrotech, which is MBPT. There are many other brands out there. So MBPT, basically the same, but We use a couple different products, the Agrotane and Amvol, and this is the two lines on top. Basically, is the yield compared to the urea baseline. Okay, so is it working? Yes, but this is also for this study we're trying to, really find kind of worst case scenario for volatilization. So keep that in mind. This is side-dress urea at the time of the year where we will expect to see more volatilization losses. And we kind of try to do the timing of application on purpose to see how these products are working. I've done a lot of this study also in the past where, we do everything, we do the treatments, and then 2 days later we have a rain. No difference. Why? Because that rain is incorporating that nitrogen, it's not going anywhere. So you guys doing irrigation, you can time also this very easily. Obviously, if you put in with the irrigation, that's not a problem. And so again, just think about in what situation you may actually see a benefit from something like this. It works, and again, when you need it, obviously we can get a benefit from it. Yes, and this is what I have here, a couple of things. So we have to think about what are the main factors driving that volatilization process. And first of all, volatilization only happens in urea. We need to have urea for that to happen, okay? So if you're using dry urea, obviously that's a situation where you have, first of all, you have potential for volatilization. If you're using UAN, that's only 50% urea. So right there, you're cutting in half the potential volatilization, right? So UAN, you're not gonna have as much volatilization potential. So again, that's a key. We need to have urea, and really what the process that happens is when you put urea in the soil, basically goes first to ammonia and then to ammonium, and that ammonia is basically the one that we can potentially lose if we are not incorporating this quickly. So what are going to be the key factors? Temperature. The higher the temperature, the faster is this hydrolysis process. Okay, so warmer temperatures is going to contribute to more volatilization. So application to sorghum is one that often worries me a little bit, because if we are putting urea in sorghum late, obviously it's hot, and we have maybe some moisture there that may drive in that volatilization a little bit more. Windy conditions, obviously, that's another factor. Soil pH, and this is, if you are dealing with high pH soils, that would be a situation where, volatilization can be a little bit, higher as well, okay? And the reason for that is because we need to have hydrogen for this ammonia to go to ammonium. We know the ammonium is not going anywhere. The ammonia is really the product here. And so higher pH is another thing that's driving that volatilization. And obviously plenty of urease, which is basically associated with residue. So heavy residue situation, if you have urea sitting on top of corn residue, that's an ideal situation for volatilization. If you're using UAN, using streamer bars or injecting that, concentrating that UAN, going through that residue in contact with the soil, obviously that minimizes any volatilization losses as well. So that placement becomes a factor there. Any other comments, questions on this?
You mentioned the placement UAN versus the dry urea. Does the dry urea, my thoughts is that maybe that gets down through the residue better, and so is.
That's a good question, and I think depends a lot on the type of residue. I agree with that. In many cases, dry urea tends to move pretty well as well. But I see in cases, one situation in particular after corn residue that we did a study, we saw quite a bit of dry urea sitting on some of that residue. So it depends a lot on the type of residue. The residue that standing, obviously that's not a problem. And so I think that's a little bit of, depends on what kind of residue we're talking about. But you're right. I mean, it could be a situation where that dry urea moves pretty well, and that would be equivalent to using streamer bars in UAN pretty much when it comes to contact. But the other factor here is also, I'm talking about volatilization, but the other factor here that may actually be more important is tie-up problems. If you think about tie-up issues, I would say dry urea and streamer bars are pretty similar, right? Because again, what you are saying, there's some movement there. But with volatilization, again, the issue is that when you have some of that urea kind of dissolve and just sitting there, and you have wind condition, that's where you tend to have more volatilization. So the really, and I'm not talking about tie-up, is another huge factor potentially. Like again, yeah, and this is basically would be, again, if you go urease inhibitor, MBPT would be one option. There are other options like nitrification inhibitors that you can use. Again, that's obviously it's going to be another type of losses. Depends on what kind of losses we're talking about. But yes, if we are expecting this, anything that has MBPT stabilizer obviously gonna help. Yep. Yes.
Has there been anything done with the stabilizers to show like the duration it helps?
Yes, and in the case of MBPT, we usually talk about 14 to 15 days. I mean, there have been, depending on the environment, we can maybe gain more, but I usually say a couple of weeks is what we are gaining from it. And so that's hopefully in that window of 2 weeks, we can have, you know, rain or something to incorporate that nitrogen.
You're not Western Kansas.
Irrigation or something, right? No, that's a good point. And again, that's why I think volatilization is something I would like to watch more.
Well, and I think, you know, where it does come in is when you get that thunderstorm that only gives you a couple hundredths and it's enough to dissolve that urea krill or wet the residue that you have UAN on. I think that's your real opportunity with the stabilizer to protect that nitrogen and hopefully catch that next thunderstorm that gives you enough rain to move that nitrogen down into the profile. Once that urea krill starts dissolving is when we run into the most problems with it.
Yep. Good point. Okay. So talking about other, and this is where, you know, nitrogen products sometimes a little bit confusing is that, you know, it kind of depends on what type of products we're talking and what kind of things maybe is supposed to be doing. And I want to show this. This is an inhibitor, nitrification inhibitor. Okay, so it's a different thing. What we're trying to do with this is basically delay the conversion to nitrate. Okay, so what is the problem with nitrate when it comes to losses? It's mobile in the soil. So what could be the problem with nitrate? Leaching, right? Yeah, what else maybe? If you have plenty of water. Denitrification, yes. But again, you need plenty of water. I don't know if Western Kansas, right? And so again, that's the key here. And so this is data from 8 site years. And actually Alan Schlegel started with this before I took over in Tribune, and he couldn't see any benefit from this. But this is anhydrous applied in the spring, okay, in March, which is already a pretty efficient system. So we have to keep that in mind. And so anhydrous applied in the spring, close to Manhattan, out of 8, we basically saw 3 site years of yield benefit. And so will this be something that I will expect to see a consistent benefit in Western Kansas? In my opinion, no. Because again, here what we're trying to do is delay the conversion to nitrate. And the problem that we're trying to tackle here is leaching or denitrification. For that, you need to have plenty of water, you know, texture, maybe sandier soil, that kind of things. And so I just don't think that we have a lot of issues of leaching and denitrification in most of our soils around here. Okay, the other thing that we started to work on is, there are plenty of products like this right now under development, is Pivot Bio. Many of you hear of Pivot Bio? Several hands, yeah. Okay, so in theory, this product basically something that what's intended to do is basically is a live bacteria essentially that basically fix nitrogen from the atmosphere. It's a free living bacteria that's going to be in the rhizosphere, fix nitrogen, and that nitrogen will be potentially available to the corn, right? So that's the theory. And we started to work on this not 20, and so this is one location that we have in Manhattan. So again, it's not really a lot of data, but I think it gives us some idea. And this, what we have here is nitrogen rates, and this basically the 2 lines is with and without Pivot Bio. And what we have here is nitrogen uptake in the plant at black layer, and this is grain yield. And so one thing that to me, and I have to say, I used to be pretty skeptical about this kind of products, okay? But there's a lot of good research going on, which make me more optimistic today. One thing that really, to me, is interesting is that we do have some, apparently some positive there when it comes to uptake. However, that is not translating into yields, okay, based on these data. And so it seems to me that, again, like I say, I'm a lot more optimistic, and I think there are a lot of good research going on, but I don't know that we are quite there yet to see that benefit translating to yields with the data we have today. And there could be many things. They do have a lot of data from Iowa, from Illinois, where, conditions are better. One thing that I talked to one of their agronomists is, what about for us in Kansas? It gets pretty hot, dry in the summer. How is this bacteria performing under that kind of environment? And maybe that's one thing that we still don't quite know how that's it's happening. Obviously, this is rain-fed, it's not irrigated. I got that question also. What about irrigation? And I don't know. I don't know how it's going to perform under irrigation. Maybe that would be a situation where you see a little bit better performance as well. But again, it's not really, what they are saying is about 30 pounds of nitrogen. So again, it's not really something that is huge also. But like I say, there are some good research going on, and hopefully we'll start to see better things coming soon. But also, there are some products that, a few weeks ago, I got this question, a product that is claiming that it's going to fix 80% of the nitrogen needs. That's a lot. I don't know if that's realistic, okay? So that's my point. We have to be realistic in terms of what to expect. 80%, that's a lot of nitrogen. I don't remember the name of the product now. And so I did went and look at the website, and that's what they're saying. But again, I like to see some research on something like that. We have to be realistic. I think that's just the one thing I want to emphasize. And with the high price of fertilizer, people claiming things like that, if you can replace 80% of your nitrogen, that's pretty good. But I don't think that's realistic. Okay, questions, comments on this? Yes, and in this product, what they suggested that we do is basically put it with the starter fertilizers. So we put it with a 10-30-40. They say within a window, I think 4 hours, something like that, we have to do the application. And this is one thing that I personally don't like very much, because if we're talking about a live bacteria mixing with fertilizer, to me that right there is questionable. Maybe that's part of the issue that we are seeing here in this data. But I also see their point, if they are saying that you have to do a separate application, separate from your starter fertilizer, that may also make things more difficult for you guys for applying, right? And so I think they're trying to balance that, how we can do the application in a practical way without affecting the performance. So I don't, that's another question.
Have you guys looked at any of the ones that are like, Sound has one that's foliar?
There are many. I actually started looking at some, and there are many big fertilizer companies getting into these and putting quite a bit of research. I know Mosaic is evaluating some products, experimental, and I did look at some of the foliar stuff, but so far I don't know what they are. It's kind of experimental, but there are some foliar as well in evaluation right now. I don't know of the commercial ones. One thing that to me, as a researcher, I guess, frustrate me a little bit is that, as soon as they are out, maybe 1 or 2 sites, they go out as commercial, which I understand, obviously this is a company, but I wish we had more data before we start to get some of the commercial products out. But you're right, there are many things, foliar, other similar, there are, with the seed, inoculants, there are a lot of activity in this area. So that may be helpful. I think we may get something that works well for our environment. Yeah, and for us, from the practical standpoint, they can do that. They can get samples, root samples, and evaluate, see if the bacteria is there. But for us, I think that's really the key. I think a lot of these, we just have to do some trials in orb farms. You know, if you can do some side by side. The problem is that this is a little bit difficult because if you are claiming 30 pounds of nitrogen, I mean, in many cases, you may have 30 pounds of nitrogen in the profile. So just cutting back 30 pounds, you may not see any difference. And so that's where this becomes a little more difficult. And so you almost have to have, you know, the full range of nitrogen rates, and especially you need to have some efficient rates to see the difference. And so that's where I think that I really emphasize anything like this, you need to do on-farm trials and see what's going on. But again, just keep in mind, it's a little bit more difficult because of the 30-pound range. Okay, so quickly, one thing I wanted to touch is also what about efficiency of nitrogen? And again, we talk a lot about cutting back nitrogen, and yes, again, with the high fertilizer prices, we should probably cutting back a little bit to target that economic optimum. But the data I show you, that maybe it's going to be 15 pounds, 20 pounds, no more than that, really what we need to cut. But what other opportunities we have, and I always emphasize this, you know, we do have opportunities when it comes to efficiency. I have a conversation with somebody a few weeks ago that, you know, he was really very aggressive in cutting back nitrogen. And he said, I don't care if I cut, you know, yields even, you know, he's really very, very aggressive in cutting back nitrogen. But I asked him, so what are you doing for application? And he said, broadcast application, urea broadcast, you know, and I said, well, you can do better than that probably, right? What can we do for improving that efficiency? And so I think that's something that we need to think about a little bit. This is one experiment, and we have multiple sites this year, and we are continuing with this. But what you have here is nitrogen rates, and this is corn yields, and the line here is basically your typical response to nitrogen, right? But this is urea broadcast at planting, just as a reference. And then the dot that you have here is UAN culture injected at planting. And very clearly, you basically have higher yields here with the same rate of nitrogen when you are injecting that nitrogen. So in other words, with the same amount of nitrogen, you have higher yields. Obviously, your efficiency is better. So we need to keep that in mind when it comes into what can we do to do a better job. And Lucas is going to talk a lot more about this, because if we have numbers like this, the question now is, you know, can we maybe invest on equipment, or what else can we do that will allow us to do to be more efficient? Because certainly we have some money there to work with, right? And so we have many, this is just 1 year, multiple locations that we have, but this is just one example. We have multiple strategies, management options, you know, obviously, you know, culture injected UAN, higher efficiency, 2x2, putting the nitrogen 2x2, more higher efficiency. Others are basically equal in terms of efficiency. So the idea with this is that, you know, with more locations, we can start to develop more of a guidelines to tell you, okay, what are you doing for your nitrogen program? And we can say, okay, you are here in terms of efficiency, or you can improve. We can play with that efficiency factor a little bit more. And Lucas is going to talk about, that's part of our recommendation right now, which is being updated. And Lucas is going to talk more about that. Yes. Yes, and in this particular location, we don't have anhydrous. I have other sites with anhydrous, and anhydrous always tend to be pretty efficient. I have to say, I mean, especially spring applying anhydrous for corn. Again, you're injecting that. As long as you're doing a good job with soil conditions, good when you are putting that anhydrous, tends to be pretty good efficiency. So I will definitely put that on top, you know, in the upper in terms of when it comes to efficiency.
Do you have any efficiency done on pumping it through irrigation?
Not on this one, but that's obviously very efficient. Spoon feeding essentially that corn. Potential for losses are low because you're not losing volatilization or anything. So that would be also another one that is highly efficient system. So again, fertigation, putting it with the irrigation system, and again anhydrous as well, continue to be pretty good one. But certainly, I mean, if you want to put if I have to choose what's the most efficient system, it's essentially putting it through the irrigation. And that's spoon feeding. That's as good as you get, pretty much. And you do have the flexibility that we just talked about. If you feel like you're a little bit short, you can maybe put a little bit more, or you can hold back a little bit. I mean, it's just as good as you get, basically. Good comments, questions. Okay. And I guess just make sure we stay on time here. A few things, always like to emphasize that, we need to look at the whole, all the program that we have and where we maybe have opportunities to improve efficiency and yields. This is data from Tribune, long-term data, nitrogen only, nitrogen plus phosphorus. With the same rate of nitrogen, obviously, we are increasing that yield significantly. Again, what is missing? What is the limiting factor in your fertility program? I think that's something that we need to pay attention to very closely. Okay. Sometimes we don't need to really change too much nitrogen or phosphorus, but what else is limiting factor? Sulfur, just quickly, I want to touch on this before we switch. Sulfur is becoming more of an issue in some of our programs, and I think corn, we've seen winter wheat obviously being the main one, but we see more and more in corn as well, especially early in the season. Seems like we tend to see some of that yellow corn oftentimes tends to be sulfur. Okay. What are the key factors here? Soil test sulfur is something that, by itself is not necessarily something that works very well. Obviously, it's a mobile nutrient similar to nitrogen. So ideally, we want to look at profile for sure. But also there are other factors. And a couple of things is texture. And we've done some studies looking at multiple soils across the state. And one thing that really comes on top when it comes to potential response to sulfur is texture. If we do have a soil that has more than 20% sand, that's a candidate potentially for sulfur response. And obviously that combined with the soil test sulfur that is less than 2 parts per million. If you have those two things together, yeah, we need to be, for sure, we're going to see a response on sulfur. And again, organic matter, like I mentioned, but oftentimes, if you have sandy soils, it usually tends to be low in organic matter. So those two kind of go together usually. And this data, again, just showing that, sandier soil, low organic matter, nice response to sulfur, fine texture, good organic matter content, no response. This irrigated corn. For wheat, one of the things that and this is something that we've done the last few years, multiple locations, look at different sources. And one of the big questions for sulfur is, do we have enough oxidation basically during the winter months to basically supply that sulfur to the wheat crop? And when it comes to elemental sulfur, what we're seeing is that, this is elemental sulfur, ammonium sulfate, and this is MESC. Obviously, a similar product would be 40 Rogue, or there's a new product also now from Nutrien. I can't remember the name now, but those are usually going to be kind of in this similar to this product. But what we see is that, fall apply elemental sulfur for wheat is not basically available for that crop. Okay, so we need to keep that in mind. For top dressing now coming up, top dressing wheat, if we think about sulfur, anything that has ammonium sulfate, if we're using UAN, putting some thiosulfate will be ideal situation. And anything that has calcium sulfate is all available, basically. Any questions? Well, I'll just touch on this. Again, we're kind of, I don't want to take too much of Peter's time, but just wanted to touch a little bit on iron chlorosis, which is always a challenge for us. And this data that I showed before, so you've probably seen around. One of the things that maybe is a little bit different kind of development in recent years is that we do have, I want to say new for us, a new chelate that also is pretty stable in high pH soils. The Europeans are the one that usually tend to make a lot of the work on chelates and high pH. They do have some high pH calcareous soils, so they deal with this pretty regularly. So a lot of this technology come from Europe. And there's one new product that I think Yara is the one that's marketing right now that is pretty good as well, comparable to the EDDHA, which is one that we've been using quite a bit and that works pretty well. Especially in high pH, very high pH soils, above 8. Okay, so the problem with some chelates is that works, but when you have pH above 8, suddenly they are not stable anymore. And so again, that's where, depending on the pH that we have, obviously the type of chelate can make a big difference. The challenge with that is that these products obviously tends to be more expensive. And so we really need to put it where it's needed. Okay. This is data for soybean with the chelated iron in-furrow application with the seed, foliar application. We've done a lot of work, typically not the same result with foliar. Okay. And again, like I say, it's highly variable in the field. And again, putting it where it's needed is really the key here. And it really becomes essentially a precision ag question here. How can we put these nutrients where it's needed? Because this one example, this is NDVI satellite, which is actually available. If you want to look at this for your fields, you can do this. This is corn, where you tend to see a little bit of a problem, but it really show up when you have soybeans, right? And so again, what we're seeing is that, if you do applications places in that field where you don't have problems, it's basically a waste of fertilizer, but you do see the real benefit when you apply where it's needed. So again, it really becomes more a precision ag question, how we can do a better job there. And again, good responses where we do have those problems.
It's gotta be put in furrow.
Got to be in contact with the seed in furrow. Yeah, that's another key factor. We also did 2x2, and as long as a little bit away from that seed, it's no longer doing what's supposed to. Any comments, questions as we are switching here for the next? Yes. No, and the data that I showed there, foliar, we done foliar and no benefit. And I think there's many reasons for that. When it comes to foliar application, obviously, how much absorption you have depends on the environment. If it is too hot, too dry, obviously the stomata is not absorbing anything. And oftentimes when you see that iron chlorosis, you have this tall of a plant, not much leaves to begin with, so I think those are probably contributing to the issue.
Even in corn.
Maybe there have been some work. I know some physiologists doing that, but my experience is with most of the time that foliar application is just not. It's not as efficient. Yeah. Yes, and I think that's part of the issue. Oftentimes, germination really becomes an issue. It may come up and just kind of die there. And so I think you start with a problem already if you are relying too much on foliar. With what? With? Can you add Yes, you can. Yes, you can. The only issue there is that obviously this needs to be in furrow, so we have to be watching rates and that kind of things, right? So if you have too much 10-30-40, that's another problem. Right. And those are some of the challenges. So I think we have to, yeah, it's ideally, in my opinion, for soybeans, I would put it just by itself, really. And the question again, these are not cheap. It works pretty well, but they are not cheap. So we really need to put it where it's needed. Otherwise it's wasting fertilizer money. Any other comments, questions?
We're broadcasting live on Facebook right now, so I had a question that came in. What would be a good phos rate for dryland corn if we are targeting 75 to 80 bushel dryland corn, and our soils are medium soil testing levels?
Yes, and if we go back to that graph, that's a good question. And again, that's dryland lower yielding, and I don't know exactly what's the soil test P. I think that's the key question here. But if we are in close to that responsive range, based on our recommendation, we're probably somewhere in that range of 20 pounds, maybe all we need. And again, that's without knowing what is the actual soil test P. But anywhere from 20 to 30 pounds, maybe is all what we need for that kind of environment. And when it comes to something like that, in my opinion, really something that you can do with a starter fertilizer. So if you have capability, you can take care of that way. Yes. This was 3 pounds of, and the one that we used was the soy green product, which is that chelate. And so that there have been some, and we did some evaluations on rates, and it doesn't really make any difference, higher rates or lower rates. Well, I guess not lower rates, but that 30 pounds is really all you need. So because this also, I got this question before, do we need to be playing about rates? And I don't know that that makes a difference. Is it really yes or no? It really becomes a question.
But you don't need to be set up on a variable because you don't want to do the whole field.
Right, you don't want to do that, and that, no, and right, and that's where the economics is. Again, you have opportunities to make money, but you have to do variable rate. You have to put it where it's needed, and that's where I like this.
More tanks and pumps on the tractor.
Oh yeah, and this is where I like this. This is NDVI from the field. You can essentially, obviously, and many of you maybe already have doing this. You can look at your field's NDVI from previous years, and you can define exactly where the problems are, because you can do grid sampling and soil test alone is not going to tell you where you have the problems. Really, the NDVI I think is a way to go to recognize where we have issues. I have to get back to you on that. My graduate student helped me to get this, but this is all free. It's all available information from satellite information. Yeah, I will get it. I mean, if you send me an email, I can send you that. But my graduate student is pretty good in GIS stuff, and he did it like in 15 minutes. So.
A lot of crop scouts will do that.
Yeah, I will say that, crop scouts, I know CropQuest. I don't know if anybody from CropQuest, I know those guys do these kind of things. And there are probably other scouts as well. They can.
John Murray ought to do it for everybody for free.
But this is very good, and I'm really glad to see this, because again it is available, and to me this is better than soil test, because the challenge with iron chlorosis is that soil test is not really telling you a lot, and so this is, I mean, this right here, the crop is telling you where you have issues.
You put that iron on, is that mobile in the soil? Is it there so it's used?
No, it's not mobile. It's not mobile, and essentially, again, that's why it needs to be in contact with the seed. And again, because of the high pH soils, that contact becomes very important. Because again, it's not going to go anywhere, and the high pH will essentially mobilize it pretty quick. So
if you have a high iron chlorosis spot in the field, if you treat it over the years, that ought to stay there and be there, or not?
Well, obviously with using these products, the rates are low. It's not intended to really build up anything. But now we're going to talk about manure, for example, and that's something that can help over time. You're putting organic matter and that kind of things. It's still not fixing the problem, but those are the kind of things that maybe can help a little bit over time. It's not an easy, I have a lot of questions on iron chlorosis, and it's not an easy fix. Okay. Thank you.